Hi, and welcome back to our fifth lesson in this unit. What are some relationships you see between the side lengths in the diagram of the cube below? Take a moment to pause here and write down three different relationships that you can see. Recognize that these dotted lines imply that it is a three-dimensional figure, and for argument's sake, it is a cube. Okay. One relationship you might see is there are multiple pairs of parallel lines. For example, ST and RU would be parallel, therefore they have the same slope, so we can write that in the symbolic form. RU, the double bar here, is parallel with ST. Another relationship is there are multiple points where perpendicular lines intersect. If lines are perpendicular, they form 90-degree angles because their slopes are opposite and reciprocal. And yet the symbol here, the upside down T, represents perpendicular. So RN is perpendicular to NO. Another relationship that you might have noticed is that there are multiple lines that are skew. So they're neither parallel or perpendicular. So we could say here QP is parallel with SO. What relationships exist between the angles of intersecting lines? We see here that each one of these lines intersects at point G, and at this point where we have DGC, we have a 90-degree angle. So write down a few of the relationships. Try to write down three of them and see what we got when you come back to the video. Lines can be parallel, perpendicular, skew. Angles may form vertical angles, which means that they are equal or adjacent angles that are complementary. 90 degrees or supplementary, 180 degrees. And remember, our little trick on that is that complementary starts with the letter C, and 90 degrees is smaller than 180. We have the letter S there. So if you listed some of the relationships you have for these angles, you might have listed some vertical pairs. For example, DGE would be congruent to AGB. Remember that when we talk about angles that form where there's multiple angles at a vertex, that we need to make sure we use three letters and that where that angle is formed, that letter's in the middle. We can have complementary. So for example, CGB would be complementary to BGA. See that these two angles here would form 90 degrees, and then supplementary with angles CGB and BGF. And we explored this in our investigation of straight line forms of 180 degrees. What relationship is this when a line intersects two parallel lines? Given that VX is parallel to SU, and RY is a transversal. So transversal means that when it intersects those two lines, it intersects them at the same angle. Okay? So RY is the transversal of these two parallel lines. To simplify this a little bit, I put some numbers here to make it easier as we're discussing the angles. One thing you might have noticed is the idea of corresponding angles. Corresponding means matching. So if I look at this diagram here, angle 1 matches with angle 3. These symbols here, the little arrows, show that these two lines are parallel to each other. So here they correspond, they match. Then we have angles 2 and 4, angles 6 and 8, angles 5 and 7. Another relationship is the idea of alternate interior angles, written as AIA when we use shorthand there, abbreviation. So angle 3 and angle 7. Now they're interior because they're between the two parallel lines. They're also on the opposite sides of the transversal. So angle 3 is congruent to angle 7, and angle 2 is congruent to angle 6. Another relationship would be the alternate exterior angles. And we have AEA as the abbreviation here, and we can see that angle 4 and angle 8 are alternate exterior. They're on the outside of the parallel lines, and they are on opposite sides of the transversal, like angle 1 and angle 5. As we looked at in our last slide, the idea of vertical pairs form at that intersection. So angle 1 and 7 are vertical pairs, therefore they are congruent. And we have 2 and 8 are congruent, 3 and 5 are congruent, and 4 and 6 are congruent. And remember back from some of the other postulates we looked at, since we know things that the transitive property, if I could say that 1 is congruent to 7, then 1 would be congruent to 3, right? Because you see here that 3 and 7 are congruent because of alternate interior, and 1 and 7 are congruent because of vertical pairs. The midpoint can also be used to help us define relationships for side nets. So a given line segment QT, how can we find the midpoint R for QT if we know the location for Q is -9, -1, and T is -3, say? Well, if we were to draw this out, we could actually take some measurements here, right? So we could add their distances. And we've been looking at triangles a little bit. I'd say, well, if I go up 4 units and to the right 3 units, that's how I would travel here, right? So I go starting at this point here, I go up 3, or so to the right 3, and I went up 4, so the new location would be coordinate point -6, 3. And we're discussing this in domain and range. Remember that those just represent our x and y values. Starting at point T, I could go down 4 units and to the left 3 units. So same idea, instead of adding in this case, I am subtracting. I end up again at -6 and +3. Well, this only works when we can use a graph to count the coordinate spaces. Since the midpoint bisects a line in 2 equal parts, an easier method would be to use a midpoint formula. So the midpoint formula, when given 2 coordinate points, x1, y1, and x2, y2, we plug it in here, and just to show it becomes the coordinate point, I kind of put it in here. So we take x1 plus x2 and we divide by 2. And think about the reason why is if we're trying to find the midpoint, we're dividing it in half. So it's half that distance there. And then the same thing for our y values. So try and use the formula here. Pause for a moment and find the midpoint for FG given endpoints 2, -7, and -8, -1. So plugging in here, remember that when you substitute in a negative number, right, so 2 plus -8, or really 2 subtract 8, -6 over 2 plus -3, and -7 plus -1 is really -7. Subtract 1, -8, and -3, -4. So the midpoint formula is a good way if we don't have a diagram to work from. That was easy. So let's put this into practice here. If we want to prove that triangle GHF is congruent to triangle IHF, given ray HF bisects angle GHI. Let's start with what do we know. So pause here and write down 3 things that you know about this diagram. Okay, you might have come up with angle HGF and HIF are 90 degrees, and we can see that from that symbol there, right? That shows us 90-degree angles. Therefore, these two are perpendicular to each other. Another thing is that ray HF bisects GHI. And remember from our definition, bisect means that it separates it into 2 equal parts. So GHF and IHF are going to be congruent. And HF is a shared side. We think about right here, splits the middle, and it's shared between these 2 triangles. So how to apply it to a postulate? Well, let's just kind of go back to what we knew from our postulates here. That would be AAS. HGF is congruent to HIF. Angle GHF is congruent to angle IHF, because it's an angle bisector, so that would be our reason. And as we get into formal proofs, we're going to want to make sure we list the reasons that go along with that. And HF is congruent to HF because of the reflexive property. It is congruent to itself. Okay, I'll see you in the next lesson.